Hello guys, in today's video we're going to learn about spanning trees of graphs in general and minimum spanning trees in particular. But before getting into the action, let's match our expectations. I'm studying this topic by myself and my videos depend on the wisdom of the crowd, a topic that really fascinates me. Therefore, if you find any mistake in what I say, please let me know in the comment section below. I promise to read all comments and re-upload if necessary. Also, please subscribe to my channel, I tend to upload many videos on this topic. Let's jump right into it. Alrighty. Minimum spanning tree. Leaf, a vertex in a graph without children. Hole, a vertex in a connected graph whose exit degree is 0. Tree, a connected graph, G equals VE, is a tree if and only if the number of edges in the graph equals to exactly the number of vertices in the graph minus 1. E equals V minus 1. An undirected graph is a tree if and only if for every pair of vertices there is exactly one simple path between the vertices. Forest. An undirected graph, G equals VE, not necessarily connected, is a forest if all its k connected components fulfill individually the term of a tree. In other words, an undirected graph with k connected components is a forest if the number of edges in it equals to the number of vertices minus the number of connected components. So E equals V minus K, spanning tree. As a reminder, a tree graph consists of edges equal to the number of vertices minus 1. For example, a connected graph with 4 vertices would be called a tree if it has exactly 3 edges. A spanning tree is a subgraph of graph G with the same set of vertices of graph G. In other words, it cannot contain more or different edges than the original graph. Therefore, the more edges a connected graph has, the more spanning trees we can find for it. Also, we cannot find a spanning tree for unconnected graphs, since we cannot add edges nor remove vertices from the spanning tree graph. Example. Let graph G equals VE be the following. This graph has 4 different spanning tree graphs. We're soon going to see the spanning tree graphs. So this one is the first one. This one is the second one. This one is the third one. And finally, this one is the fourth one. Minimum spanning tree. A minimum spanning tree is selected among all possible spanning trees, and it is the spanning tree with the lightest subset of edges. Let us look at the previous graph. This one. Say that this graph is given with the following weights. So the edge between A and B equals 1, the edge between B and D equals 2, the edge CD equals 3, and the edge CA equals 4. Among all possible spanning trees of this graph, we want to remove the heaviest edge, E equals AC. In other words, this one is the minimum spanning tree of this graph, because we removed the heaviest edge, and yet we left the graph as a tree. And this is our minimum spanning tree. Well, that's the story. I hope you learned something new from this video, and please comment below with your thoughts. First degree studies in university are all about social studies, and this project comes to encourage that, even through complicated situations most of us are going through right now. Please subscribe to my channel and comment with your thoughts. I hope to see you soon. Good luck!